Well, thank you very much for your nice introduction. I'm happy to be with you again. I'm also happy about the invitation. Let me welcome all spectators everywhere. That's the starting chart of Professor Willner with his data. Well, we talk about climate protection, this big issue. The discussion has become highly emotional in the meantime. And, well, as a matter of fact, we talk about a phenomenon of natural physics, the change of the climate. And, well, we have to observe the laws of natural science and physics. That we cannot negotiate about that. And in the current situation and in the planned legal situation on German and international level, things don't always go into the right direction. So very quickly, let me illustrate what the math of physics for climate protection means. This is the key chart for this purpose. We get the data from the World Climate Council, IPCC, and we need two figures for this purpose, the so-called CO2 residual budget, which we may put into the atmosphere for a certain heating goal of 1.5 degrees. And now we are in the mid of 2021, and the residual budget is 280 gigatons of CO2 to be put into the air to abide by the 1.5 degree goal. Then the annual emission goal, which is 40 gigatons per year of CO2. Well, there's a simple calculation, 280 divided by 40. This means 7 remaining ridiculous years if we cannot save CO2 globally. These are less than 2 legislative periods. If we were to begin with real CO2 emission reduction from now and follow a green ideal line, which I call correct action scenario here, then we would at least double the time to 14 years. If we wait for another year without doing anything, then we have to come down in 12 years' time. So if we wait for 1 year, we lose 2, and so on and so forth. And if we continue for another 7 years, then nothing will be left anymore. Let's keep this in the back of our minds, which, because it has clear consequences for actions of climate protection, no matter where they are to be undertaken. Here you see it, no delay, no greenhouse gas export and fast rollout. That's how I put it in English. Hence, we need to start now without postponing any action or taking action with a delay factor. That would be the no delay criterion. No GHG export means that it doesn't make sense to do climate protection actions in one sector, which lead to higher CO2 emissions in other areas. And the last, just as example, as important, is the fast rollout, since we talk about a global task, not about a national one. Small example, Germany stands for 2% of the greenhouse gas emissions worldwide. And even if we were to eradicate Germany from the world map, we wouldn't even save these 2% because oil and gas would not become cheaper because of that, and there might be more consumption elsewhere. So those countries which now produce coal, oil and gas would have to leave this in the earth, whilst other ones cannot even take an active influence on it. The only thing we can do now, which also goes for Germany and Europe, is to roll out technologies worldwide, which then stand for smaller demand in the energy sector. And if we break it down to road transport, we find that the criteria no delay can only be fulfilled now by alternative fuels. And that means liquid and gaseous ones. Hence, we also talk about hydrogen. But we also talk about the gigantic fleet which need to be involved, namely 1.4 billion vehicles worldwide. In electric mobility, unfortunately, there is a built-in delay, a delay of 5 to 15 years, because the increasing CO2 emissions for the construction of batteries need to be reduced, and this takes as long as until we reach zero before we can start saving. So it's just like putting a car on a racetrack or a racehorse, but you put it the wrong way round and it runs full speed into the wrong direction, hence an increase of the CO2 emissions first, then it comes back to the starting point 10 years later, and then it starts with CO2 emission reduction. That's electric mobility, to put it very clearly. Now, GHG export, I mean, the net reduction, of course, is very good. In the available biofuels, we have already reached more than 80% in terms of performance improvement. That is excellent. In electric mobility, unfortunately, we have a very large exportation to those countries which are in charge of battery production. And I don't know whether the political minds don't want to understand that the CO2 which we take into the air in China maybe goes into the same atmosphere as the emitted CO2 in Europe. And yet electric mobility is counted in with zero emission. Now, fast rollout, the international cooperation is the key component in climate protection. We need to go into the world, and now we have the possibility to use renewable energies in countries with excess of energy exportation, but supplying a business model at the same time whereby the excess production is sold back to us in green fashion in the long run. Thus, we take wealth and stability to those countries, and the other way around, our gigantic energy demand can be satisfied. For Germany, this means 70% and EU-wide 58%. Potential. Thus, the answer is clear. There is a large number of studies confirming all this, even that all the three criteria can be fulfilled. And well, there's still another aspect to it, something which crops up as a mistake in calculations, namely that no renewable energies are taken into these new systems. Hence, we need many more alternative fuels, both gaseous and liquid. We have 5 families of alternative fuels. The first, which are already on the market, the second on waste basis, biogenic waste, and the third, which is non-biogenic waste. And then hydrogen plays a role in the large issue of the e-fuels. I've mentioned it within the scope of international cooperation, and then the combinations of fewer high biomass or wastewater production or as hybrids. Well, here a short description. Hydrogen is a key molecule for future mobility, be it in direct applications, in fuel cells, be it through the large platform PDX. You see the chemical formulae, which are explained at the bottom. Hydrogen and CO2 are brought together from the air in order to produce liquid green molecules, which we then re-import to Germany and Europe. And once we have the green molecules in the country, these liquid fuels, then it's much more efficient to turn them directly in electricity or in combustion energy instead of transforming it into green energy first and then putting it into fuel cells or batteries. In Hamburg, at our HAW, we develop hybrid processes, and it can give you a figure illustrating the efficiency. If we consider the hydrogen demand and all the other demands for electricity, if we put it in kilowatt hours needed for electric power over a distance of 100 kilometers, then we have 5 kilometers. And this is better by a factor of 3 to 5 as compared to hydrogen-operated vehicles. Well, here, let me quickly point out that there are 3 things which need to be revised on EU level: the ID2, fleet regulation system, and the energy taxation regulation, where renewable fuels are taxed fully, which need to be amended. And here 3 open letters which went to the EU Commission this year. And, well, you can download this and read through it in good time. These are scientific contributions and scientific contributions. And with this joke on the last chart, I would like to thank you for your attention.